All right. Like I explained, this is chemistry, and here is the first question. Let's see. It says, which of the following is not correct? I'm going to bring those options, okay? So here are the options that we have. And this is the way we're going to do it. I'm going to be starting with Moses, okay? Moses, you have
So,
in a few seconds, read this and try to pick your option. Yeah, you can read it out.
I should read it out.
Yes, read it out, then you pick your answer.
Mhm. Which of the following statements is not correct? A. The average kinetic energy of a gas is directly proportional to its temperature. B. At constant temperature, the volume of a gas increases as the pressure increases. C. The pressure of a gas is inversely proportional to the density. The temperature of a gas is directly proportional to its volume.
Now, the question is, do you even have any idea of what the question is asking you? He said which one is not correct, but these are some principles stated, right?
Yes.
Okay, good. So, do you have any idea of which one you think should be the answer before we even look at it?
D.
Did you say, is it D for dog or B for baby?
D for dog.
D for dog. Okay, you said the temperature of a gas is directly proportional to its volume. So it says which of them is not correct, right?
like, once you
Oh,
choose. I
not
said,
correct.
Yeah, not correct. Take note. Not correct.
A.
A, right? Right?
Yes.
Okay, I think you went for D because you already know that's a correct fact, right?
Yes.
That the temperature is proportional to its volume. How is the temperature proportional to volume? That is, the higher the temperature, the higher the volume. The lower the temperature, the smaller the volume, right? Is that what you mean? Can you hear me? Can you hear me? Hello?
Sir.
Yeah, I mean, did you hear what I said? Did you hear what I just
Mm-hmm.
said? Okay. I said you pick the last option, which is D, because you already know that is a confirmed fact, right?
Yes, sir.
Okay. And that statement actually said the temperature of a gas is directly proportional to its volume. That means the higher the temperature, the higher the volume, and the lower the temperature, the lower the volume, right?
Yes, sir.
Okay, fine. That's the meaning of the direct proportionalism we're talking about here. Okay, now the A that you pick that maybe is not correct. The average kinetic energy of a gas is directly proportional to its temperature. That is also correct. You know why? Listen, you know why? When you supply heat energy to any particles, any substance, the particles receive enough kinetic energy and they begin to vibrate. And if it's a liquid, at a point, it begins to boil, right?
Yes.
So, the higher the energy you supply, the greater the temperature and the greater the vibration. Okay? Is that clear?
Yes, sir.
Good. Let's consider B. B said at constant temperature. When you leave the temperature at a constant, let's say 100 or and whatever, It says the volume of a gas increases as the pressure increases. Let's think about that. If, okay, hold on, please. If there is a gas in a container, let's say you have this container, can you see this shape? Can you see the shape?
Yes, sir.
Okay, good. Let's say this is a gas container and you have gas particles in it. Let me put some particles like filling it up, okay? Is that clear?
Yes, sir.
This is gas that I put inside. If I open the container up, if I open it up here, and I'll begin to, okay, let me just try as much as possible to. So now begin to push the container downward, okay? To press it to make it go, downward like this, okay? Is that clear?
Yes, sir.
Now, do you know the gas particles at this place will be added to this other region, right? Is that clear?
Yes, sir.
So, um, I am trying to reduce the volume. Is that correct?
Yes.
Then the particles become so much more right now. Is that clear?
Yes.
So what happens to the pressure there as as I reduced the volume, reduced volume, right? So what happens to the pressure? Is what? Increased, right? Right?
Yes.
Or did you say reduced? Can you hear me?
Yes, sir.
Uh-huh. So the pressure will be increased because they will collide faster, okay? Because what?
Equal light faster.
They will collide faster. So, but look at what the second statement said. It says what? At a constant temperature, the volume of a gas increase as pressure increases. That's not true, okay? So, as we increase the pressure, did the volume also increase? It reduces. So, is that option B? Is it correct?
Yes.
Now, I mean, it's not correct, right? But that is our answer. Is that clear? So, do you agree with that? Okay, very good. So, um, that's the way to approach questions. Okay, can you hear me?
Yes, sir.
Okay, good, good. So now you know why. And if you go through Boyle's law, it states that of the pressure and volume of a gas have inverse relationship. Okay, if the volume increases, then the pressure will be relaxed, will reduce. Is that clear? But if the pressure uh, increases, the volume reduce. If you reduce the volume, the pressure will become great. Is that clear?
Yes, sir.
Okay, very good. Now we can move to the second question. So it's not about how far or how many questions you're able to answer in an exam. It's about how well you answer those questions. Let us assume you attempt 50 objectives and you answered 30 correctly, and all the 30 you answered they are correct, you did not answer the remaining 20, my friend, you have passed that exam. Because why? You have even scored more than half. You answered 30 and the 30 are correct. But if you answer 50, only 5 are correct or 10, then it's of no use. Is that clear?
Yes,
Yes,
sir.
sir.
Okay. This next one, let me see. Number two is asking us something about zinc oxide. And this question is going to belong to Mercy, okay?
Yes, sir.
Okay. So for Mercy, let's say, I'm going to bring the options, okay? So, Mercy, over to you. Which option do you think is correct?
Was that is amphoteric, like C.
Okay, yeah, that's correct. It's amphoteric. Now, another question can come and ask you, why is zinc oxide amphoteric? What do you mean?
It's amphoteric because it has either basic or acidic property, like that both properties together. It's
Okay,
that
okay. So
basic.
that means it will dissolve in both acids and alkali.
And
Okay.
yeah,
It will dissolve in both what? Acids and what? Alkali. Yeah. So by God's grace, I'm going to make the video available so that when you watch also, I mean whoever needs any explanation will remember, okay?
yes, sir.
So the next question goes for Sarah,
Which
number three.
Want something else?
Number three, let's listen. Let's listen. So I'm going to bring the options to this.
You want to write down the H in
I'm going to bring the options, okay?
the
So now, Sarah,
finger. Check.
yeah, Sarah, read it.
When sodium chloride and metallic sodium are each dissolved in water, both processes are exothermic. Both processes are endothermic. C, the dissolution of metallic sodium is endothermic. D, the dissolution of metallic sodium is endothermic. E, the dissolution of sodium chloride is explosive. Both processes.
Leave the explosive. Come on, I'm
So,
reading everything. Anyway,
so which option do you go for?
yeah.
You go for A, right?
Yes, sir.
Okay. Now the main thing is that these are part of the concepts that you just need to study and retain in your memory. Because if I ask you, have you actually dissolved sodium chloride and metallic sodium in water personally before? You understand me? Have you done that before?
No, it was
Have you done that before?
not
So,
Answer the question. Have you yourself dissolved these two substances in water before?
no.
No. And neither have I. Are you getting me? So to be able to remember this kind of concept is that when you are studying and you get an information and say, okay, when you know this is your table salt, right?
So,
Good. And metallic sodium, you know, if you must have put salt in food before or in soup or in something, right?
Yes, sir.
If you put salt in any, your table salt, if you put it in any food item, or maybe you just add it to water, let me put it that way, do you see any heat energy given off into the environment? No. Okay, are you with me?
Yes, sir.
So you might not tell because you are not even measuring the, you don't have any tool around you to measure whether there is heat given off. But physically and visibly, you did not see any heat when you put salt inside water. Okay. Okay.
Yes.
Unlike when you drop something inside water and it just, do you know this drug called Andrews liver salt?
Yes.
Yes.
If have you ever used it before? Have you poured it inside water before?
Yes,
Yes.
sir.
What is the experience when you pour it inside water?
Bubbles.
It bubbles and just like giving off something, right?
Yes, sir.
That
Justice.
is that is exothermic. Okay, that is what.
Exothermic.
So it gives out heat to the surrounding. Okay, is that clear? That
Yes,
kind of
sir.
that kind of reaction gives heat to the surrounding. But have you ever poured methylated spirit on your hand before?
Yes, sir.
Yes.
Methylated spirit, like all this,
Egyptian.
I don't know. They use
No.
it in treating wound or something like that.
Okay.
Methylated spirit.
Big injection. What it was your ear?
No, not it's inside a bottle, transparent stuff like this. Wait,
No, this
wait,
with
hold on, hold on,
this one I'm doing this.
hold on. Okay,
Still going.
hold on.
I'm not
I
This
want
is
to
annoying.
I want to see if I can get, yeah, I think you should be familiar with this particular image. Let me see. Methylated spirit, right? So, do you know this?
Yes, sir.
uh So if you pour small amount of it in your hand, just tiny amount or whatever, after some time it disappears. Yes or no?
Yes.
Yes.
It evaporates, right?
Yeah.
And your hand feels, is it hot or cool?
Oh.
Cold.
That is because it is taking away heat from your hand. Okay,
Yeah.
then your hands will be at a lower temperature, then you feel coldness. So any reaction that absorbs heat from the environment is called endothermic. Okay,
Yes.
good.
Oh,
So for
sir.
the metallic sodium is
Yes,
highly
sir.
sodium is highly corrosive. Okay, that's why we can see it in hydrochloric acid, a very strong acid. Is that clear?
Yeah.
A corrosive acid will be exothermic in nature. It can explode. All right? Is that clear?
Yes, sir.
But ordinarily, chlorine dissolution is not explosive because it's not an acid. But because it has the property that is, it's highly corrosive, then we can go for the exothermic. Okay?
Yes.
Is that clear now?
Yes, sir.
Eh. So, when picking an option, we should try as much as possible to study, when small quantities of sodium metal is added to water, there is an exothermic reaction. They react to form sodium hydroxide and oxygen. Take note of that, okay? Is that clear?
Yes, sir.
Yes, sir.
Okay. We're going to move to the next question now. This question will be for Moses, okay? So, Moses, here is your question. Hold on, I'm going to bring up the options, okay? I'm going to bring up the options. So, the option, this is asking you. Yeah. So, Moses, you can read now.
The periodic classification of elements in an arrangement of the elements in order of their A. Atomic weight, B. Isotopic weight, C. Molecular weight, D. Atomic number, E. Atomic masses.
So, what's your option?
Hmm. Atomic number.
Yeah, that's correct. Okay. Is that clear?
Yes.
Yes.
So, number one on the list has atomic number one. Okay. All right. And number 20 on the list has atomic number 20. Is that clear?
Yes, sir.
And there are other things associated with that, which we can briefly discuss. For an element, for example, sodium, to have atomic number what?
So,
11. Okay. It simply implies that sodium has 11 electrons, okay,
yes, sir.
and 11 protons, but 12 neutrons, okay, and the atomic mass equal to protons plus what?
Neutron.
Neutrons. So that means for sodium, the atomic mass will be 11 plus 12, which is what?
23.
Right.
23. Is that clear?
Yes, sir.
So if you're given any particular element and you've been told how many electrons are there, definitely you might be able to get the atomic mass, or you should be able to know the number of protons and the neutron if you're given the atomic mass and the atomic number. So take note of that. So Henry mostly arranged the elements in the periodic table by their atomic numbers, and this gave rise to the statement of the modern periodic law. And to further explain that, the periodic law, are you listening?
Yes, sir.
So the periodic law states that that properties of elements are periodic function of their atomic number. That is, no two elements with different atomic numbers will behave the same way. Is that clear?
Yes, sir.
Good. So let's go to the next question, which is going to belong to Mercy. So let me see something.
Okay.
Hold on. Okay. Here is a question from Mercy. Let's say, okay, that's the number one. That should be number three. Then it should be number four. Or what? This is 1, 2, 3, and 4, and this should be 5. So here is a question, and I'm going to bring the options to see. So the options. So Messi, you can read.
The reaction between sodium hydroxide and sulfuric acid solution. What volume of 0.5 molar sodium hydroxide will exactly neutralize 10 centimeter cube of 1.25 molar sulfuric acid?
So do you have any idea of what it's asking or how to go about it?
Let me solve it first.
Okay, let me give you 1 minute to go through that. So, so you're
Alright,
you
so,
said
pick C.
okay, you pick C, right?
50, 50, 5%.
50. Okay, 50. Can you explain further? How did you get it done?
Since we're given reaction between, give us the volume of molar sodium hydroxide, which is 0.5,
Okay.
and she neutralize. So, um, so I'm not even sure my answer, but the way I did it, sure.
Hmm. So
About
that
50.
means you need some explanation. The answer is correct, but probably you're
Uh,
like, okay, this question, but do you really understand the concept or how to get the answer?
so I go to my method.
Hmm?
So, I used another method to explain, but the one I did, I don't know, she arrived at 50.
So I'm suspecting maybe you've seen the question repeated before and you're like, this is supposed to be 50.
No, no, no.
Okay,
So I don't
okay.
want.
No problem, no problem. So the first thing to do is to get the equation of reaction between the two substances, okay? We have sodium hydroxide reacting with sulfuric acid, okay? Which is
Yes.
H2SO4. H2SO4, okay? That is tetragosulfate 6 acid.
Let me draw
So,
that to the one.
630, is it the same thing as sulfuric acid?
Yeah,
Yeah.
okay. Now,
Okay.
we have various kinds of sulfuric acid, trigosulfates, tetragosulfates. You understand me? So now, when we add this together, what is going to happen is that the sodium is going to displace the hydrogen, okay?
Yes.
Then it will become sodium Na2SO4. Why should sodium that is ordinary 1 now become 2 here? Listen. It's because this ion is SO4 2 minus. Okay?
Yes.
To neutralize it, you need two positives. Is that clear?
Yes.
Yes, sir.
Yes.
Hydrogen is one positive. Okay? So whenever you form a product with SO4, whenever you form a product with SO4 2 minus, the cation that is coming to join that anion has to be twice or has to be two positive. If it's only one, for example, do you know that calcium is two positive, right?
Yes.
So if it is calcium that was coming, it will just be CaSO4, okay? Not Ca2. Is that clear?
Yes, sir.
Because calcium in itself is two positive. But this, the ones we're considering, like sodium, it's only one positive. That's why twice or two of sodium must combine with the anion of two negatives. Is that clear?
Yes, sir.
Then, when the hydrogen has been displaced, hydrogen doesn't have anything to do than to join the remaining OH. Is that clear?
Yes, sir.
Then, if hydrogen join the other hydrogen, it becomes two hydrogen because we can't form three there, okay? If we form three hydrogen, it won't give us water. And neutralization reaction always gives salt and water. Is that clear?
Yes,
Yes,
sir.
sir.
That is plus H2O. So the next step is to make sure this is well balanced, okay? You have put two besides, under sodium, then this must be two molecules. Is that clear?
Yes,
Yes,
sir.
sir.
Then let's see if it's
Hydrogen.
balanced. Then we have to put
Hydrogen.
two here too, okay?
Oh,
Is that clear?
Yes, sir. Yes.
yes,
So
sir.
the hydrogen is now 4, and the hydrogen is now 4 on the left, 2 times 1 here and 2 here, making 4. Sulfur remains 1. Oxygen is 4. Oxygen remain okay, oxygen is what? 6 on the left
No
side.
balance. Yes, no balance.
What did you say?
You know, by
Sir, what did you hear? Shut up. What did you hear?
2 years.
2 years,
Wait.
4 years.
Wait, calm down. 2 oxygen here, right?
No.
Oh, don't touch your screen.
Hello. One
Sir?
by one. 2 oxygen here, right?
Yes.
Yes.
And how many oxygen here?
4.
4.
Making 6, yes or no?
Yes.
How many oxygen here?
4. 4.
And how many oxygen here?
2.
2.
Is it balanced?
Yes.
So what is the what is the one that is not balanced now?
No, they are all balanced.
They are all balanced. Okay. Now, since you have known that, then you should be familiar with your formula CAVA, okay, over CBVB
BB
equal to what?
plus NA over NB.
Where Na over Nb is the mole ratio of acid
And 2
to base.
and 1. 2 over 1.
Wait, calm down. Calm down, okay? Is that
What's
clear?
it?
How?
Hello, listen.
Sir?
Are you listening?
Yes, sir.
Yes.
Good. Acid over base. The base is 2, not 1. The acid is 1. So this is going to give me 1 over 2, not 2 over 1. Is that clear?
Yes.
Because if you go and use 2 over 1 instead of 1 over 2, you get another answer. So what is the concentration of acid given in that question?
It was before. No. Sodium.
Concentration.
Hydrogen.
Wait, concentration. This is concentration of acid, volume of acid, concentration of base, volume of base. Now check that question. What is the concentration of acid and what is the concentration of base in the question?
1.25.
What is that of acid? Yes.
I'll say 1.25.
1.25.
Let me check. Sulfuric acid, fine. 1.25. What's the volume of acid given?
10
0.5.
cmk.
Hmm?
0.0.
Just say volume.
Volume,
Volume,
10
volume,
cm
what's
cube,
volume?
right?
Yeah, okay, 10.
Over,
0.5.
what is the concentration of base given?
It's not
0.5.
given.
Still be not given.
Times
Uh,
the volume
times
of
B.
base. You are looking for VB, right?
Please leave given.
It's not given.
Mm-mm.
Hello.
Leave given.
What are you looking for?
BB.
Uh-huh.
Volume.
So equal to this. Then you cross multiply, okay?
BB is not given.
Is that clear?
Yes, sir.
So 1.25 times 10 is 12.5 times 2. What is 12.5 times 2?
3.
No, 12.5 times 2.
3.
12.5 times 2.
25.
25. Is that clear? Then divide both side by what?
0.5.
That is where the 50 comes from, okay? So if you say 25 divided by 0.5, that will give you what?
50.
50. Is that clear now?
Yes,
Yes.
sir.
50 cm cube. So it's not just about saying, yeah, I think it should be 50, but about knowing how to do it. Is that clear?
Yes, sir.
Okay, fine. Let's see if we can look at one more question. Then we'll round up the class for today. Okay. The question is supposed to be for who?
So,
Sarah. Okay, Sarah, get ready.
One is
So, Sarah, read this. Read out. Let me hear, Sarah.
a small quantity of solid ammonium chloride, NH4Cl, was heated gently in a test tube. The solid gradually disappears to produce two gases. Later, a white cloudy deposit was observed on the molecular part of the test tube. The ammonium chloride is said to have undergone distillation.
So, which option do you go for?
Sir, A.
A, which is distillation, right?
Yes, sir.
Okay, let's look at it. It said solid ammonium, blah, blah, blah. That what you need to know there is the state of matter, okay?
Yes, sir.
So, solid and was heated gently in the test tubes. The solid gradually does what?
disappears.
Okay. Then it produced what?
Two gases.
Okay,
Produces sugar.
two gases. So forget about the rest of the story. Okay. Solid to gas without passing liquid stage is called sublimation. Okay.
Yes.
And that is where we'll be rounding up the class for today. So is the class interactive?
Yes.
Yes, sir.
Okay. So, and we're going to meet tomorrow for physics by the grace of God, okay? All right.